Alright, so next example is about how to instance uh, objects to particles. And here is a little example. So I have three different objects, torus, sphere, and box. And they are copied through copy node to particles. So here I have just particles. Alright, so let's take a look how it works. I will create a new node. So I create a geometry, and first I need to create the particles. And excuse me, not particles, but pop network. All right. And let's say I want to emit from sphere. Change to polygon like this, and popnet. Yeah, I need source. Source, surface. Let's say ordered. It's really doesn't matter. So first input, and I have particles, but have no velocity. So like this. So now the particles are emitted from sphere and flying away. Great. And now let's add a few different objects. So let's say torus again. Torus, box, and let's say cylinder, tube. All right. So now I need create a switch node like this. So I can go through and switch. Polygon, yeah, all right. And now I create a copy. And here again, I talked about this node in one of the first lectures. I'm going to use a stamp expression. And here I need to connect primitives to copy, so this one, and here template to copy to, so my particles. Currently, and let's set transform node to all of them and change the scale. All right, so currently if I play the animation, I will get this. A lot of toruses are flying away, flying around, and yeah, that's nice, but not what we want. And in copy, I'm going to stamp inputs. Let's call it objects. And let's say random from $ID, where ID is a particle number. All right, and the value must be fitted between 0 and let's say 3. Okay, but if I play now, nothing will change, will be different. To make it work, I need to go to switch node, and here in select input, I need to type an expression, stamp, open brackets. Here I set the node I want to use, and this is copy one. Okay. Next, I need to set the variable name, which is objects. Objects and default value in case if something goes wrong. All right. And it looks like something goes wrong because, oh no, now it works. But why I have a complaint, bad parameter. Uh, yeah, okay, probably it's complaining because I have to copy nodes. No, it's not. That's strange. Let's do it. Oh, well, yeah, okay, now it's fine. So yeah, so you see I have cubes, tubes, and toruses attached to my particles. So you basically can instance anything you want. All right. And next node I want to tell you about is color. So I can assign a color to the particles. Yeah, but now it's applied to all of them. Well, if I want to have a different color for toruses and different color for cubes, it's easier to do it on this level. So instead of applying color here, it's easier to do it there. Like this. So now I have different colors. Well, it's definitely possible to do it with the same copy with a stamp function, but it's just easier and faster. All right, so now let's talk about rendering particles. Here I have a simple setup, just source, force, and drag force, and particles are emitted from sphere, and that's how it looks. So I will jump to some interesting frame. Okay, so let's say something like this, and uh, let's create a camera. All right, and some environment light and area light, like this. So let's see how it looks. Okay, not bad. But currently you see that the particles are really huge. So there is a way to control them. Let's dive back to PopNet. And inside of PopNet, we have a render node. So let's connect this. And yeah, I need to pause my rendering because now you see it takes a recalculation. All right. So in render node, we have activation, particle type, particle size, and particle blur. Uh, First, if I change my particle type from sphere to, let's say, lines, and render it. It's not updated. Um, it should render in different style. Okay, let me check. All right, so the thing is why it doesn't have effect on my render is that particles have to be cached before you applying render. Otherwise, it will recalculate the whole simulation each time, which is really expensive. So to cache particles, I can create a file node. It's actually a good practice to cache the particles because if you're not going to resimulate, it just faster. So okay, I will save my scene. Um, Particles, let's say number 2. Right, and now I can cache my uh, particles. So I will create a geo folder, um, particles $f4. Okay, and now I need to rewind, and instead of read files in file mode, I should set write files. Switch to node, and I need to go through the whole simulation. So let's wait a minute. All right, and while it's caching, I will tell you one more thing. Instead of using file node, which is okay, I used a render operator geometry. The difference here is that the geometry node allows us to set the frame range I want to cache, and here on bottom it allows to uh, cut away few different fields, for example from pyro simulation. So it can save a lot of disk space because the fire simulations and water simulations can be amazingly huge. Okay, and this simulates a bit faster just because it don't have to update the viewport. So it took just a minute, and in a few seconds it will be ready. And the file node here is, I will disconnect it and just read files here this from this node. And again, remember that you can procedurally control the path to the files. So for example, if you have this path in the ROP geometry, you can automatically update it in the file node so you won't miss your files. And just to remind you how to do this, I will show you this in a second. Alright, so simulation is done, and I disconnect this as I told you, and read files. So now I can disconnect. Alright, and I can deactivate all these nodes for now, and I can play my cache. And once it's cached, I can scroll back and forth, and this will be fine. In file node, I can set my particles representation into bounding box, for example, so this will be really fast. I can change to info, so this will be like one point cloud, which feels even slower than particles. Well, it should be slower because it's doing dual conversion. It's reading file, converted to uh, point cloud, and then showed up. Well, packet disk primitive. Uh, Packet primitives are a new feature in Houdini 13, and I will talk about it in one of the next lectures. But for now, let's leave it as all geometry. Okay, like so. And let's render. One important thing about rendering in Houdini, which I forgot you to tell about. Here on top, you can see the preview checkbox, and if I click it on, it will be like dynamic IPR. It, but it's a ray trace. It will stay a ray trace no matter what I do with mantra node. So if I create a new mantra, and camera one, and render is set to micro polygon, for example, mantra one, render. It's still it's a ray trace. This will be always a ray trace until you have a preview checkbox turned on. So I found it a bit frustrating because I've been setting up a render and I had a different picture in viewport and in mplay, so it took me a while to figure it out. So to see the real result, I would recommend to turn off the preview. And you see immediately it renders different. So yeah, so now it's a micro polygon. It says so here. Physically based rendering, and PBR is quite fast. So you see that it renders the scene way faster than micro polygon. And ray tracing is also quite fast, but PBR is the fastest one for particles. All right, so let's go back to render node. And it looks like I cache my render node. So this doesn't take effect. And I don't have it here. Okay, it looks like render node is working on the inside of the popnet, and I haven't found a way how to bring cached simulation into popnet. All right, so in that case, let's go back. Let's delete rope. Then important thing is that uh, to change, if you change something, and to make the render node work, you have to resimulate the whole simulation, which is not really nice, but that's how it works. All right, let's render. And now you see I have as disks, so it looks flat. If I change to tubes, nothing happens because I have to resimulate. All right, and yeah, and to resimulate, I need to go one level up. Well, that's really strange. Well, in new popnet, they add a button reset simulation like in top networks, but here that's a bit weird because Well, it looks like it's not simulated, so this should work now. Yeah. Okay, so now it renders as tubes, spheres, these lines, capit tubes. It's kind of strange that you have to resimulate it each time because this can be done like I showed you previously with stamping, so you don't have to resimulate it all the time. But that's why it's old, and probably that's why they create a new pop system. But okay, let's say I want to render it like this, and particle blur. All right, there is one thing that you can add motion blur to the particles. And here in sampling, we have allow motion blur. I turn it on and nothing happens. Well, that's correct because to make it work, we need to go back and on object level, I need to select my sphere, and in render, in sampling, there is geometry velocity blur. So this should take the velocity and use it as motion blur. Uh, funny to say, but I was looking for motion blur because I thought that it's not here, but it is actually here. It was just really subtle. Yeah, well, to make it stronger, we can increase geotime samples. So let's say 10 and render. And yeah. Well, this effect can be really subtle, but uh, this is this is really nice. So okay, you see it's here. However, while I was looking for the solution, I found one interesting thing. The particles, which I cached previously, it is possible to bring them into simulation. So let's turn off this, and I will create my file node again, like this, and let's yeah, okay, I crashed, so I'm not in the same folder, but um, p particles geo um, should be here. Yeah, okay, let's activate this. All right, read files, particles. Oh, okay. I forgot to set an extension to files, so okay, I will cache it again. Um, well, frame range, let's say 100. My current heap is in temp, so I need to save it again in right place. Particles 2, okay, overwrite. Alright, so now I can cache. So hit render and wait a bit. Okay, so now particles are cached. Turn off this and let's read it from here. Okay, so now I have cache of particles. All right, and let's render it. So now my particles are rendered as spheres. And let's say I want to get the benefits of this render node on this level, on geometry level. Right, and I had a problem here, so I create a new scene and just load the cache, as you can see. And to render the cached particles with different representations, so disks, tubes, and lines, there is a primitive node. So you create primitive, connect your cached particles, and here is a particles tab where you can set render type. So now the particles are spheres. Now it will be like capped tubes. Rounded tubes. So all the different types of the rendering lines. So that's how you can control the particle representation after you cache it. One important thing I forgot to tell you about is in a PopNet there is a start time, pre-roll time, random seed oversampling. So what it's doing, I will decrease amount of particles just to make it work faster. So start time is basically tell when the simulation will start. And it works in seconds. So let's say 3 seconds. And my simulation starts here. All right. And here is also pre-roll time. So let's say the simulation starts on second 3, but I want to see the simulation in state of second 6 or 10. So I type 10 here, play up to here. And on frame 72, it starts to calculate 10 seconds of pre-roll. And that's how it looks. So the pre-roll is really useful. Yeah, so particles are really nice. All right, so let's keep talking about particles. And now I will show a few more things, which is pretty useful. And this will really help you to understand how to use particles and get something useful from it. All right, so once again, we have an empty scene. Let's create a geometry. Geometry node, the same particle setup. So pop network old. And yeah, let's create a location. So particles are working. And now let's talk about what do we have more here. Uh, First, as you may remember, we can create a birth group. So let's create one group and let's preserve it. So the particles are in group. And now let's create the force. And apply some direction to it. Alright, and rewind, play. So I have particles, which is moving in this direction. And now let's say I want to limit them somehow or put in group. Here is a simple way, which called limit, I believe. Should be, or bound. Okay, let's try bound. So body limit, yeah, limit. So this node has a box picture, which is pretty nicely describes what it's doing. So let's do it like this. By default, it creates an insanely huge box. So this is kind of useless for now. So let's create it way smaller, like so, and maybe even smaller. Yeah, something really tight. All right, so let's play. And now you see that particles are dying once they hit the wall. All right, this is nice, but I can switch to sphere like this. All right, let's get back to the box. And here I have a behavior. So there's a different types of behavior. Die collision, which is happening now. Bounce on collision. Stop on collision, so they will like stick on the surface. And continue on course. This looks pretty similar to goal object or follow, where we had no, not here, but in previously I was showing you the node where it was possible to control the behavior. Okay, I don't remember how it's called now. And yeah, obviously it's collision, so I can choose what to do if it's collided. All right, and the same with collision node. I can create collision event, collision group, and hit index is standing for creating the index for particles which has been collided with surface, so we can split them later. All right, so that's a limit node, and for sure I can apply it only for just born particles. And I have no effect, no wrong behavior. And oh sure, my birth group is the particles are here in the beginning. So okay, so that's the limit group. Now let's talk a bit more about orbit, the orbit node. So if I connect my particles to this um, and play the animation, nothing will happen for now. Well, that's fine because here on the settings, let's start from center tab. I can select a center group, and this can be a surface or any group. So let's say yeah, okay, let's kill this. Now center group. This can be a center point like this, and I can override it by these values. So let's say 5. So now the particles are attracted to the center and orbited around it. I can attach any surface or any object into this. So let's say I want to uh, attach another particle, and I will create a location. And let's say I will emit just few particles. Let's say 1 for now. All right, and let's move a bit the birth point. Right, let's play. And I need to turn off override. Okay. And I can change to different types like this. So now the particles are following my personal particle. All right, now let's create just few particles and add some velocity. Let's say I want to create 5 particles. And you see now they like split it. All right. What I can do with this, in orbit tab, I have different parameters. So let's say I want to override axis. And by doing this, I can rotate the orbit. Next parameter is radius. So it works like this. And I can override speed to make them almost stop. Okay, well, slow them down. So now you see the circles are almost static. And yeah. And scale, controlling the speed of attraction. Something like this. Okay.